week's topics covered decoders and multiplexers, and in this week's lab we'll be focusing primarily on decoders, specifically the BCD to 7 segment decoder, which I think is really cool because you get to use another aspect of your Nexus board, which are the 7 segment displays, and I think they're pretty fun to use and very useful. So in lecture 7A, I've already described the BCD to 7 segment process that you'll need to follow for the lab. I'm going to go ahead and open the lab assignment here. So this lab consists of 3 experiments, experiments 6, 7, and 8, and they all build upon one another. So I would recommend doing them in order. Create a project for experiment 6, do experiment 6, and then copy that project, rename it to be experiment 7, and then modify it to do the objectives of experiment 7, and then similarly you can copy your project 7 and then modify that to do experiment 8. Now, as noted above here, there are no ISIM screenshots required for this lab report. That means you don't have to use ISIM for this one, but you still can if you'd like to use it for testing. I only need a report and a demo for experiment 8. That's because experiment 8 builds upon 6 and 7, so you don't need to create a procedure for 6 and 7. Just go ahead and write the report up for experiment 8, do the procedure, the testing, and everything for experiment 8, but be sure to include the answers to questions for all experiments. So you'll see at the end of each of the experiments there are some questions, so be sure to answer all the questions in your lab report. Okay, so the BCD to 7 segment decoder was already explained in the video, but again, with every lab that you do, you always want to start with a black box diagram. So in this BCD to 7 segment decoder, we need to consider what are our inputs and what are our outputs going to be. Now remember, for the 7 segment display, you have both anodes and cathodes. Now what do I mean by that? Well, let's go ahead and open up the pin assignments. So remember, in order to turn on a display, you need to turn on the anode for that display. So if you want to make display any of these least significant displays, you need to turn on AN3. Or if you wanted this leftmost display to turn on, you need to turn on AN0. So these are known as the anodes that select which of the 4 displays you want to turn on. You could have them all on at once if you wanted. And then you also have the cathodes, A through the G, and then the decimal point, which control which of the 7 segments or the decimal point you turn on. So recall then that you're going to need outputs for both the anodes and cathodes in order to configure the 7 segment display. Let me go ahead and open up Paint. Our black box diagram, we'll start with a box, and we'll give it the entity and name. I'm going to call it BCD to 7 seg, and we already know we need 2 outputs. One of them is going to be our anodes, and one of them is going to be our cathodes. I'm going to call this one my segments, S-seg, and that's going to be 8, a bus of 8, because we're going to have 7 segments plus the decimal point, and then the anodes are going to be of width 4. I'm going to call that AN. And then we also need inputs, and since this is a BCD to 7 segment, we're going to have a BCD input. And how big is that bus? It's going to be 4, because our BCD digits are 4 bits long, because remember, we're representing the numbers 0 through 9, and 9 is the largest number requiring 4 bits. So this is our black box diagram for the first experiment, experiment 6, and you go about creating the decoder as described in lecture video 7A, and then you also need to add another signal assignment statement to turn on the appropriate display with the anodes. Then, like the ripple carry adder, you'll have to individually map the bits of each bus to the appropriate pin numbering for the UCF file. So BCD sub 3, BCD 2, BCD 1, and BCD 0 all need to get mapped, and you use the mappings given in this this chart. Okay, So that's experiment 6, 7, and 8, or your lab 4.